Sultan, allow all the participants, registered participants.
Allowed, sir, allowed.
Share the YouTube link to all the groups, Sultan, including our group.
Sir, our chief guest, sir, has just in Dr. P.K. Khosla, sir.
Oh, sir, good afternoon.
Good afternoon, sir.
Good afternoon,
Good
all.
afternoon, P.K. Koshla, sir. Good afternoon, sir.
Good afternoon, all present. How are you?
Fine, sir. How are you, sir?
Good to interact with the what is it, western or southern part of the country?
Southern part, sir.
Okay.
Southern part, sir.
Great. Good
Our
to see.
director, sir, is also joined.
Also,
sir.
this is Dr. Raja, Director, NSRIT Pro, sir. I think, Prasad, you can take off, no? Wait to wait.
The members are joining, sir.
No, sir, wait to make sir to wait, I'm telling you. You can take off.
Yeah. Yes, sir. Sultan?
Sir, yes, sir.
Yes. Is it streaming? You please share
Yes, sir.
the streaming link to all the members.
Yes, sir. Already streamed, sir.
Streamed. You share the links to participants and allow all the
Yes, sir.
participants.
Shared,
also.
sir. Shared, sir.
Allow all the participants also. All participants. We'll wait for 1 minute and we'll start.
It's okay. Take your time, please.
Yes. We'll wait for 1 minute, sir.
Right.
Few people are still joining. Yes, you can take off.
Good afternoon. A warm welcome to one and all. Myself, A. Gautami Naidu, Assistant Professor, Department of ECE, NSRIT. We welcome our Secretary, Dr. N. Prasad Raju Garu, Treasurer, Shri N. Kankaraju Garu, Director, Dr. J. Raja Murugadas Sir, Academic Advisor, Dr. Shesharao Garu, HODs of other departments, faculty fraternity, and all the participants from the various institutions across India for the 3-day faculty development program on emerging trends in electronics and computer engineering from 27th to 29th October. We also welcome our eminent speakers and today's chief guest, Dr. P.K. Khoshla Sir, Pro Vice Chancellor, Chitkara University, Punjab. Now, let us inaugurate the session with lighting the lamp by HOD and staff of ECE department.
Oh.
Thank you, sir. As a tradition, we start the FDP with a prayer song by Ms. Vaishnavi.
शरणु सिद्धि विनायका शरणु विद्य प्रदायका शरणु पार्वती तनय मूर्ति शरणु मूषिक वाहना भक्ति मुक्ति न पदक हरणे बाहुहस्त चतुष्कले इट्टि तुडगे हेम कंकन पाशांकुश धारणे शरणं शरणं.
Thank you, Vaishnavi. I request our convener of FDP, Dr. Shivaprasad Sir, to address the participants.
Thank you, Gautami. Good afternoon, one and all. I once again welcome all the participants, all the faculty fraternity from various institutes across India, and especially welcome our today's chief guest, Dr. P.K. Khoshla Sir, Pro Vice Chancellor, Chitkara University, Punjab, and I welcome the Director of NSRIT, Dr. Raja Murugadas, and all heads of the departments, all the faculty fraternity, and all the participants. So once again, welcome to the 3-day FDP. Today, I especially thank all the members who are going to participate in these coming 3 days for a wonderful session. I thank all the resource persons starting from Dr. P.K. Koshla sir and Dr. Manish Kalla, Assistant Professor, NIT Jalandhar, and Dr. Vinay Lochar, Data Scientist, Data Org, Gurgaon, Dr. Sachin Kumar Srivatsav, Assistant Professor, IIT Roorkee, and Dr. Anvesh Kumar, VIT Bhopal, Dr. Sripada Raja, Product Manager, Intelligence India, and Mr. Ajay Termakar, Senior Scientist, Semiconductor Laboratory, Mohali, and Professor Jafar Ali Khan Mohammed sir, IIT Hyderabad, and Dr. Abhay Sachdev, CSIR, CSIO Chandigarh. So I thank all the members who are accepted for this day as a resource persons. So my kind request for all the participants to utilize this opportunity effectively and enhance your skills in your research area wherever it is possible. So I congratulate all the participants and organizers for this event. Thank you one and all.
Thank you, sir, for your words. I request our respected director, sir, Dr. J. Raja Murudhar, sir, to address the participants.
Thank you, Gautami. At the outset, I would like to congratulate and compliment the entire team of Electronics and Communication Engineering and the organizing team headed by Dr. Virender Singh for organizing this 3-day FDP on the latest trends in the Department of ECE. And at the same time, I would like to thank Dr. Koshla for accepting our invitation, as well as all the resource persons for participating in this 3-day FDP. I have only one request to all the participants is please try to utilize these resources, as all the resource persons are from reputed institutions of like IITs and NITs and other leading research universities as well as laboratory. So wish you all the very best. Once again, I would like to thank all the organizers for organizing this 3-day FDP. Thank you. Thank you, Virender. Thank you, Prasad.
Thank you, sir. Thank you very much, sir.
Thank you.
Thank you so much, sir. I call upon co-convener of FDP, Dr. Virender Singh, sir, to introduce our today's chief guest, Dr. P.K. Koshla, sir.
Yes, ma'am. Thank you. Good afternoon to all of you. I am Dr. Virender Singh. It is immense pleasure to invite Dr. P.K. Koshla, sir. He is presently the Pro Vice Chancellor at Chitkara University. He is currently contributing in strategic planning and intervention towards the world-class university and developing and strengthening the research ecosystem. He has authored one book, several book chapters, numerous national and international papers. During his outstanding 33 years tenure in Defense Research and Development Organization, DRDO, his determined and relentless efforts have enabled scientists to identify the previously unforeseen and latent issues in the defense system. And one of the best example of it, sir has put the foundation of embedded system division in DRDO. He was also associated with the Center for Development of Advanced Computing, CDEC Mohali, India, as its executive director. Dr. Koshla sir experience and credentials have held a high utility in all the organization he worked with. He has led multiple teams working in the area of cybersecurity, healthcare technologies, e-governance, artificial intelligence, supercomputing, agri-electronics. Under the leadership of Dr. P.K. Koshla sir, CDEC Mohali recorded the ever highest revenue surplus in 33 years of existence. His contribution in the field of science and technology have been acknowledged widely, and thus he has received several awards of eminence, like the Digital India Award 2020 in the category of Innovation in Pandemic from Honorable President of India, the Coveted Scientist of the Year Award 2015 from the Honorable Defense Minister of Government of India, and commendation, sir received commendation from Chief Secretary Haryana 2021 for leading Emergency Response Support System Dial-Up 112 in Haryana. So these are not over. So many more awards sir is having, or sir is acknowledged for that. So today topic for a little bit focus on innovation in healthcare technology. So without wasting even a second, I would like to invite Dr. P.K. Koshla sir. Sir, please.
Thank you, Dr. Virender, for such a generous introduction. Before I start, let me load the presentation that I wish to. Can you enable me to share my PPT?
Yes, sir.
Unta.
Yes, sir. Yes, sir.
Hello, sir.
Hello, sir. You can share now, sir.
Okay.
So once again, thank you, Koshla sir, for your acceptance, and we are very, very happy to be part of this, sir. Thank you, sir.
Thank you. Is it visible?
Yes,
Yes,
sir.
sir.
Visible, sir.
Yes,
Visible,
sir.
sir. You make it full screen.
Visible, but not full screen, right?
Okay, sir.
Okay, it's full screen. Fine, fine.
Yes, fine, sir. It's fine. Very fine.
Okay, just one minute. At the outset, let me thank all the organizers for giving me this opportunity to share my views with an audience which is on the other part of the country. And I especially thank Dr. N. Prasada, Secretary, NSRIT Visakhapatnam, Shri N. Kanakaraju, Treasurer, NSRIT Visakhapatnam, Dr. J. Raja Murugados, Director, NSRIT Visakhapatnam, Dr. Shiva Prasad, HOD ECE, and especially Dr. Virender Singh, who's ever enthusiastic. I've known him for quite some time, contributing his bit in every activity that is assigned to him. I was thinking about, like, what do I share in such a August gathering, and something which is different from what you are going to come across during the FDP studies. I formally welcome all FDP participants also who are going to benefit from this course, and I'm really happy that NSRIT has chosen this topic and has taken this initiative of educating our teachers on a very apt topic. Now, I was thinking, let me start with the innovations, because to my mind, innovation in the country is the most important part, because the prosperity in any country comes by virtue of innovations. You can see all developed nations have had good number of innovations, and all those innovations were acquired with the sheer hard work, with the exception of Gulf countries, wherein it is more due to the resources rather than the innovations, but then they are also taking rapid strides in the field of innovations now. So I thought, let me talk about innovations, and that we are all combating a healthcare crisis in terms of the COVID-19. So healthcare technologies took a lot of new innovations and new forays into this domain. So I thought, let me apprise you all of what has been our contribution, my present organization or the previous organization, what have we done in this regard, which can be really inspiring for some of you. To my mind, the creation of fire on demand can be considered one of the most important innovations that mankind had seen. The primitive man, he learned how to rub these stones and produce fire. That was an invention indeed, and that changed the course of history of the mankind, because humans learned how to develop more calorific food, and once we started eating more calorific food, the brain size disproportionately increased. The brain size of the maybe elephant might be more bigger than the humans, but the proportionately higher brain is of humans, and that's one reason we became more intelligent than rest of the beings. And then rest, you all know that all other species who were not friendly with us vanished, and we could only survive. So I consider that as a big invention. No one knows who did that. Same way, there was somebody who converted this invention into an innovation, that they created a fire on demand. So this indeed, fire on demand is an innovation which has some commercial value as well. And just to add to some more forays of India in this direction, is Prime Minister Modi himself had announced that India today ranks 40th in Global Innovation Index. And our journey has been, in 2015, our global rank was 81. And you can see from this graph, it has jumped from 81 to 66, 65, and so on. And we have the lower the rank, the better it is. We are amongst the top 40 now. So 40th rank is the India's global innovation rank today. And every year we are improving upon it. But then 40 is also not a cozy figure. We are not amongst top 10. So we have to continue our journey into innovations. And if I say invention, any new product, any device, or any process which had not existed earlier can be considered as an invention. And this invention doesn't go into technology alone. It can be into toys, it can be into food, it can be into sports, or it can as well be into musical instruments. So that is what is invention. But then today, the focus is not on as much on invention, as much on innovation. So let me say that anybody who knew that if the hot air is passed through, or hot compressed air is passed through coffee, it will brew. And this is what is an invention. This can be considered an invention if it is done for the first time. So the hot air from a pressure cooker, a compressed air, is passed through the coffee to brew it. So this is indeed an invention if it is done for the first time, but then no one will buy it. It has its value today in current day scenario only if it is converted into an innovation. And this is what, now this I can call it's an innovation, right? So innovation is something beyond invention. It has some commercial aspect to it. It has to be some translation research is to be done so that it becomes an innovation and something which is commercializable. Now, moving on to, I'm going to cover rest of it focused on the healthcare technologies, because COVID presented the largest challenge before the healthcare community. So what has been the foray and what are the opportunities in this domain? Let me apprise you of that. The Government of India's own initiative is Ayushman Bharat Digital Mission. Earlier, it was in the shape of National Digital Health Mission. Now it is Ayushman Bharat Digital Mission for more than a year now. And under this mission, every citizen of India will get an ABHA ID, that is health ID of every citizen. So the health record of every citizen would reside in some repository, which can be retrieved as per his consent. And the system is, the owner of that data is the person himself, whose data it is. It's like your money, you will keep it in bank and you can choose which bank. It could be the government bank like SBI, it could be a private bank like HDFC. So same way, your health record mapped with that ABHA ID would reside in a health record. And that health record, again, you have to choose for how long it will be shared with whom. And after that, they have to erase it. And those health IDs, those health records can be in the government sector or in the private sector, which I'll explain a little later also. Same way, in the ABDM, Health Welfare Facility Registry is being established. This healthcare facility registry is something like what are the diagnostic facilities, what are the hospitals, they will all register with the ABDM, and that will be accessible to all those who have a ABHA ID, and they can fix up their appointment with the direct doctor, and they can look for particular specialization, who's good in that and whom would they like to consult. Same way, a lot of health apps are being developed. They will all be passed through the sandbox of the ABDM. And the biggest advantage that is going to be an accelerator in the healthcare ecosystem is this interoperability between the different healthcare systems. So those healthcare systems will conform to the sandbox of the ABDM. Today, if I develop one system, somebody else wishes to utilize that, he need not talk to me. I will publish my API, and through that they can use it. Now, similarly, there will be a registry of healthcare professionals. All doctors or nurses or healthcare providers will have to register here, otherwise they cannot practice. So this ABDM is a very big initiative of the Government of India, which is going to take shape now, and it will be a good technology spinner, which you all can benefit from. Now, as I had stated, COVID-19 posed a healthcare challenge, which was ever biggest before the humankind, which was challenging its very existence itself, but then we could combat it based on many technologies that came up. We all know the necessity is the mother of invention. So since COVID was there, many new things happened. And one of those, some of those are either as shown here, the initiatives that we took, which I'll like to cover some of those. The healthcare solutions were made, some AI-based healthcare technologies were developed, many healthcare devices came up. And one of these in which, while I was heading CDAC Mohali, we developed a telemedicine solution. We developed, Virender, let me know when I'm supposed to end, or I'll continue for maybe another 25, 30 minutes.
Sir, you continue, sir. Continue.
Continue, sir. No issue, sir.
No issue.
Okay, thank you. Thank you. Now, till about March 2020, the telemedicine was allowed only between doctor to doctor teleconsultation. It was not possible to carry out patient to doctor teleconsultation. It was on 25th of March 2020 that government declared that now the patient to doctor teleconsultation is legal in India within the boundaries of our country. It can be from one state to other. A doctor in Kerala can provide a teleconsultations to a patient in J&K, but not beyond the boundaries of India. So before that, we had one solution which was doctor to doctor, but with the onset of COVID, we worked for about 18 days, day in, day out, and came out with one solution which provided patient to doctor teleconsultations also. And this teleconsultation system was pitched before the Ministry of Health and Family Welfare. They accepted it. They started promoting it before the states, and gradually almost entire country adopted it. 35 states in India accepted this solution. This solution comprises of what you see, an embedded image of a doctor. You see the image of a patient above that, and the demographics of the patient is fed there. The doctor can write the prescription based on SNOMED CT standards, not that they can write anything they like. So it has to prescribe to certain standards. There is a compliance. Earlier, you could not read the prescription slip, but today it was computer-generated prescription slip, which is signed by the doctor, which is honored by the chemist, and you can buy medicines against that. And government departments are giving reimbursements also wherever it is. That eligibility is there because all doctors in this system are the government doctors. And this is available free of cost to every citizen. You can utilize it from the laptop or from the mobile phone anywhere, and every state it is there. So this is how it took off. And just one moment, it's okay. Now, health in India is a state subject. So rolling out technology is one part. Its proliferation by the Ministry of Health and Family Welfare is another part. But then it is incumbent upon the respective states to promote it so that their citizens know and utilize those services. So every state came out with its own promotional material. What you see here is something in Haryana, Punjab, Rajasthan, and UP, right? And this is what the press coverage, media also started covering it in different states, in Maharashtra, in Himachal, in Jharkhand, and so on. So you see the people started getting on board on eSanjeevani platform. This is called eSanjeevani. The telemedicine solution so developed is called eSanjeevani. It is branded as eSanjeevani. And very many innovative cases which are rising by the day for monitoring the patients under quarantine, for monitoring the HIV patients who are to be given the repeated medicines, some critical ailment monitoring, or the inmates in the jail who need not come in person before the doctor. So all those innovative cases started apart from the regular OPDs which were around the country. And these figures are a little old. And today, more than 6.5 crore teleconsultations have taken place. It's there in 35 states in India. And we take pride in saying that about 3 lakh teleconsultations every day is being carried out on this system. Now, you can see the rise of this. December 19 was the time when the initial COVID had appeared at Wuhan. And at that time, we were ready with the doctor-to-doctor teleconsultation. But in April 2020, if you can see my cursor, this was the time when we launched the eSanjeevani, the patient-to-doctor teleconsultation. And thereafter, you see the graph has been rising every month. Some small rise can be observed, which coincides with the onset of the COVID waves in some cases. And the blue one is the one where the system is available from health and wellness centers, where the ASHA workers facilitate the teleconsultation, and The orange one is the one wherein the orange one is the one where the teleconsultation is between the patient and the doctor. So total teleconsultations have been rising every day, and this has been a big success in the country. We have emerged as the largest in India in this respect, providing the teleconsultation solution. We will not be surprised if we become largest in the world. Many ministers in various forums have offered it to other countries as well, and slowly you'll see it becoming global. Now, Virender, are you located in Telangana or Andhra Pradesh?
Andhra Pradesh, sir.
Andhra Pradesh. So, oh
Yes,
my
sir.
God, Andhra Pradesh is the topper in this. I would say you look at it. These are little old figures, maybe of the month of July. So you look at these figures. How much is it? It is something like 2.3 crore teleconsultations have been carried out in Andhra alone. So that's a phenomenal figure. They are using it in the good numbers in patient to doctor teleconsultation as well as in the doctor to doctor teleconsultation. So this is a success. I'm very happy to see that Andhra has taken such a big lead in this, where they have become the toppers in the utilization of this. But I feel the audience who are from other parts of the state at this moment should benefit more from it, that they make others aware that they can utilize these services. Now, having achieved such milestones, the awards come calling. In most cases, we didn't even apply, we started getting award. We got the eGov Award 2020, we got Scotch Award 2021, we got Jury's Choice and Gems of India Award, we got Digital Technology Sabha Award, and on top of it all, it was adjudged as the Digital India Award 2020 in the category of Innovation in Pandemic with the Platinum Award. That's the first award given in this. And me and my team received this award from Honorable President of India. So that's the innovation, homegrown innovation, I would say, which has been duly acknowledged on the various forums. And taking cue from there, many private sector organizations have also come up. It's Pharma Easy, M-Fine, MediBuddy, or Teladoc. So many of them, they are coming out with their own innovative models wherein they allow appointments with the doctors. They provide many newer services which are not part of the eSanjeevani. eSanjeevani 2.0 is about to be rolled out by the government maybe in another month or so, which will have many more advanced features. Another initiative I would like to point out to the audience here is the Heal in India initiative being taken. You see, a bypass surgery in US costs upwards of 45,000. A bypass surgery in Israel costs about $16,000. But in India, it costs only $9,000. And we have competent doctors, we have fabulous healthcare facilities available. So under Heal in India, we would looking forward to inviting a lot of audience from abroad, a lot of patients from abroad who would come and get treated here, and in the process giving us the scarce revenue that we look forward to for growing and taking the country to the next level. As I had been mentioning, the health record of every patient would reside in a repository. The government repository as the My Health Record that CDAC was developing. This is what is shown here as eHealth 102 record maintenance services, wherein the prescription or the prescription slip or the bills, the laboratory reports, the discharge summary, all those can reside in the government database, and any database that the patient chooses, and that can be retrieved wherever he may be, in whichever country he may be, he can easily access that. That's the My Health Record I am showing here, which is the initiative from the government side, which CDAC Mohali is implementing. The other opportunity today is that no patient would like to visit a hospital which is crowded. So for a 3 minute of teleconsultation or 5 minute of a consultation with the doctor, physical consultation with the doctor, the patient has to hang around for almost entire day. He has to travel from far off place, reach there. There's a traffic jam. There is a crowding in the hospitals. So let the technology take care of it. Let the patient be presented before the doctor through technology only when he's required. So those solutions should get developed in due course, and they'll be in good demand. Some of the artificial intelligence based solutions which we had worked on, I would like to point out that the mixed reality is going to be as popular as the artificial intelligence. You see, if you wear the see-through glasses, which is called HoloLens or Smart Glass or GeoGlass or Google Glass, all those things. So the person who's wearing the glasses gets a lot of information about the victim or about the target or about the patient, and his hands are free to work on it. So he views the context information. Let's say you are repairing an aircraft. Your hands are free to work on it, but then it tells you what is the assembly procedure, whether the part is available in the inventory, and which one to do first, which one to do next, what will be the flow of the whole process. And same way in the medical field, if the doctor is operating on a patient, he gets a whole lot of information in front of his eyes, which is superimposed on the patient, and his hands are free to perform the surgery. This is what one of the smart glasses, which can directly sense even the pulse and many more parameters of the patient. Now, one part I want to apprise you of is many challenges are posed by the chronic eye diseases. Those diseases are all amenable to artificial intelligence based solutions. Now, these solutions, one of them is age related, I mean, the diseases. Let me apprise you of the diseases and then the possible solution to those. The diseases are, one of them, I would say, just 1 second. See, glaucoma. Glaucoma is a silent killer of the eyes. The eye pressure increases and the nerve in this portion gets pressed and gets damaged. In the process, the peripheral vision of the patient gets damaged and he cannot see what is the. I'll show on the left hand side is the image of which you see with the normal eye. On the right hand side is the same image seen with some disease in the eye. So in case of glaucoma, what you see is only in the center, and on the periphery it's all dark. You are not able to view the peripheral, I mean the vision on the periphery. So this is a silent killer because the patient feels he can see, no, he can still see the face, but gradually it narrows down until a person becomes blind. Now this is open to diagnosis by the artificial intelligence. The other part, age-related macular degeneration, AMD. Here in the center you cannot see, on the periphery something can be seen here. Same on the left hand side, you see through the cataract. If the normal eye can see an image on the left hand side, but on the right hand side a blurred image would appear if the cataract is there. And if it's a diabetic retinopathy, again you see the patches, what is shown on the right hand side. And then we built under a funded project, we built an artificial intelligence based model, and which detected these images, and these images were labeled with the government doctors. They were trained using these images, and a model with more than 95% accuracy was developed, wherein you present any image and it'll tell what disease it is. But in India, the telemedicine guidelines mandate that the artificial intelligence based diagnosis can be shared only with the doctor and not with the patient. So that one has to take care of. But then still there are many use cases. For example, a diabetologist would try to know whether there is a diabetic retinopathy without involving an ophthalmologist for a early screening. So there, this system can provide information to the diabetologist. That's one example of a mixed reality, wherein the whole eye 3D image can be visualized by the trainees or the trainee doctors. There cannot be any better way than visualization through the mixed reality. We also came out with one proposal, we call it E-Drishti Samadhan. This is the AI-assisted teleophthalmology, which we propose to present to the health and wellness centers. More than 1 lakh health and wellness centers are already operational in the country. And if they are given such solutions, the patients need not travel to far off places. The diagnosis can be done, and those who need immediate intervention can be attended to. To wrap it up, I would say technology is a double-edged weapon. The knife can be used to stab a person, but the knife can also be used to perform a surgery. So I would request all the audience to focus on the technologies which benefit the mankind. And with this, I'll sum it up. Let me say thanks for the patient hearing. And if there are any questions from the audience, I'll be glad to answer. Thank you so much.
Thank you, sir, for your valuable information.
Dr. P.K. Kroshla, sir, thank you very much for your presentation too today about latest technology, even post-COVID and everything. Once again, we thank you very much, sir, for today's participation and presentation. Thank you very much, sir.
Thank you, sir. Thank you. Okay, may I take leave?
Sir,
Yes.
what is the mixed reality you are talking about? I'm a little bit confused. How many field this is touching? Machine learning, deep learning?
Yes, most of it was on machine learning, yes. And then mixed reality.
Okay, sir. Okay, sir. Okay.
Okay, right. Thank you. Everyone.
Thank you very much, sir. Thank you very much.
Thank you.
Okay.
Now I request our coordinator, Dr. K. Ravikumar, Professor in ECE Department, to give vote of thanks.
Good afternoon to all. I, Dr. K. Ravikumar, Professor ECE. It's been immense pleasure to present vote of thanks in inauguration of 3-day FDP on emerging trends in electronics and computer engineering. I, on behalf of Department of ECE, NSRIT, convey deep regards and heartily thanks to our Honorable Chief Guest, Dr. P.K. Khoshla, Pro Vice Chancellor, Chitkara University, Punjab, for his speech. Your kind presence in the FDP encouraged us a lot and made us more confident in our persistence to make this FDP a grand success. I would like to thank our management, Sri N. Sachinarayan Raj Garu, Chairman, Dr. N. Prasad Raj Garu, Secretary, and Sri N. Kanakaraj Garu, Treasurer, for providing necessary resources for smooth conduction of this event. I also thankful to Dr. J. Raja Murugadas Garu, Director, for helping us in obtaining the necessary administrative approvals and guidance for organizing this event. I also thank our academic advisor, Dr. A. Shesharao Garu, for encouraging us to conducting FDP. I would like to thank Dr. B. Shivprasad, convener and HOD ECE, for his moral support and make this event success. And also thank to Dr. Virendra Singh, co-convener, Professor B. Ravichandra, coordinator, and all ECE staff of NSRIT for their support. I would like to thank all participants for your interest shown and accepting invitation to participate in this event. Thank you, one and all.
Thank you, sir. Now I hand over the session to Dr. Manish Kalda, Assistant Professor, NIT Jalandhar, to speak on machine learning and its applications.
So now I request Dr. Virendra Singh to
Yes,
read the brief bio about Dr. Manish Kalda, sir.
Yes, sir. So I would like to invite Dr. Manish Kalra. He's been expert in machine learning and has done PhD on analysis and time frequency technique for moving ground vehicle detection and classification using seismic signal processing. He explored the various time frequency techniques for moving ground vehicle recognition. The seismic data sheet of moving ground target is generated by using the vehicle like bus and tractor. The novel target detection and classification algorithm have been proposed, and the performance of this technique have been evaluated on the implementing on the generated data set and on the standard data set. Right. Then Dr. Manish Kalra is having a wide research and teaching experience, starting from lecturer in Polytechnic College, then assistant professor in Department of Electronics and Communication Engineering, UIET Kurukshetra University, and followed by assistant professor in NIT Jalandhar. So where he's right now he's doing. So what is machine learning and how this machine learning is getting, how electronics and communication researchers are getting attracted towards it, and the importance of machine learning, basics of machine learning, and all the applications. Now I would like to hand over it to Dr. Manish Kalra. Welcome, sir.
So welcome,
Thank
sir.
you.
Welcome once again. Welcome, sir, Dr. Manish Kalra, sir. Thank you for accepting our invitation to be as a resource person for today's session, sir. Thank you, sir.
I'm very thankful and you invited me for the talk. It's my pleasure. And particularly, I would like to thank Dr. Virendra sir for contacting me and inviting me for this session. And I would try to make this session a bit interactive. Interactive means I would expect most of the participants to be interactive. Can you see my?
Wait, sir. Wait, sir. Wait for 1 minute.
Yes, sir. Can I start? Am I audible? Dr. Virendra,
Sir,
am
you
I
are audible,
audible?
sir. You can continue, sir.
Yes. Can you see my screen? Can you see my screen?
Yes, sir.
Can you
Your
see my
screen is
screen?
visible. Your screen is visible, sir. You can continue, sir.
Can you see my screen?
Yes, sir. Yes.
Yes. Yes. In today's session, we will be learning the basics of machine learning and its application. And I would request the participant to make this session interactive by asking the questions. Means this session is not going to be one-way session; it is going to be two-way session. I will be having some basic questions, and I will be expecting some answers. And after then, we will be having one basic example of machine learning. I will be showing you the Google Colab, and we will be doing one machine learning application, basic one. Now, as sir talked about AI, means P.K. Khosla sir was talking about the artificial intelligence, and sir showed some of the very interesting applications in the field of medical. Now, my question is, what is AI? What do you think about AI? Yes, please. Any participant? Yes. What is AI? What do you think about AI? Any guess? Yes. Can you hear me? Any participant?
Sir, good
Yes,
afternoon,
sir.
sir.
Yes, please.
Audible, sir.
Sir, good
Yes.
afternoon, sir. Good
Good
afternoon, sir.
afternoon.
Sir, utilization of resources.
Okay. Artificial intelligence. Yes. Any other participant? Any other participant? Okay, the artificial intelligence is something, means as the name suggests, it is artificial intelligence, means the intelligence is being produced artificially, means we are using computers to have the logics, to have the reasoning, Means all these tasks are being done artificially. Means we are creating intelligence, but it is artificial with the help of computer. Means computer is taking its own decisions, right? Now the question is, why do we talk so much about AI? I mean, at present era, means everyone is talking about the AI. I mean, in the previous presentations, discussed a lot of applications of AI. Now, can anybody answer why do we talk so much about AI? Why now? Means everybody is talking about AI. The question is why? Yes. Any participant? We are talking about
Sir,
AI.
to reduce human efforts.
To reduce human efforts. Very good answer. Yes, sir. Any other participant? Yes, very good answer. To reduce the human efforts. Nowadays, we are having the chatbots. With the help of chatbots, we are interacting. Means it is eliminating the need of customer care personnel. Right. Very good answer. Yes. Yes. Any other answer? Any other suggestion or something like that? See, because it has reduced human efforts immensely, even in every field. Like we are having CCTV cameras, and we can detect if some thief is going here and there, and automatic detection is possible. And sometimes when we are driving, and if we are not following the rules of traffic, then we get the challan at our homes. Right, it is all because of the AI, because this number plate is detected, right? And sir showed some very interesting applications based on artificial intelligence, right? Because of this, so much benefits of AI, like reducing the human efforts, doing the things automatically, and because nowadays we are having the internet. Because of the internet, we are able to generate the huge data set. And another thing is that because of the gaming, we are having the hardware, and this hardware, availability of hardware is one of the reason for this popularity of AI, right? Because of the hardware, because of the data, because of the internet, and a lot of funding. Means the big companies like Google, Facebook, AI are spending millions of dollars in the research of AI because of that funding and that hardware and the data. There is a revolution in AI at present. Actually, it is third wave. Initially in 70s, 80s, and then now in 2011 to now, we are having so much research in AI and so much applications we are seeing nowadays. If we see the application domain, then we are having application in almost every field. In engineering, we can see the applications of AI, whether it is civil engineering. In civil engineering, if we want to know the health of a structure, we can use this artificial intelligence. Even in the electronics and communication, to get the optimal length of the channel, we can have the simulations. And in the case of healthcare, as sir discussed, we are having lots of applications of AI. And in the next session also, we will be having healthcare applications using AI. In business domain, there is a revolution because of the AI. We can see various banks are using artificial intelligence to detect the fraud, and so many applications we are utilizing the data set, and we are providing the good services to the customers because of the AI. And further, whether in science as well, in the basic sciences, in physics, we are having the artificial intelligence. Those people who are using means the optical resources, material engineering, we can see lots of applications of deep learning and the machine learning. Now, further, we can have many applications of AI. One second. AI in everyday life. Can you suggest some applications that we use in everyday life? Any participant? Any participant? Yes. AI in everyday life. Can you suggest anything that you use in your everyday life from AI? Any participant? Any guess? Yes.
Sir, inventory control, sir.
Pardon?
Inventory control, sir. Inventory control.
Inventory control, right. A very right answer, sir. In inventory control, we utilize artificial intelligence to manage the database and all those things, right? Any other?
Sir, Google Assist.
Pardon? Google Classes?
Google Assist.
Assist. Okay, right. Okay, yes. Any other applications? Any other applications? Yes.
Driving cars.
Driving cars, self-driving cars are the thing, but at present, when we spend our day, and most of the day we are using artificial intelligence. When we see some video in YouTube, then we get the recommendations, and those recommendations are based on the artificial intelligence and machine learning. When we are having a photo on Facebook and those faces are text automatically, then it is because of the artificial intelligence. When we do Google research, then Google search, and the search engine gives us the topmost matching keywords. It is also based upon the artificial intelligence, and means everything. Most of the things that we are using are based on the artificial intelligence. Like I gave the example, like nowadays traffic police is utilizing artificial intelligence to generate the challans, and these are the applications that we are doing, that we are utilizing in our day-to-day life. Now, my question is, what is the future of AI? What do you think? Yes, any answer? Any participant? What do you think? What is the future of AI? Yes, can you guess? Actually, sometimes we divide AI into two domains. One is weak AI, another one is strong AI. The weak AI, like that we are using, YouTube and all that. Then further, in strong AI, in the future, we can have the self-driving cars. We can see more and more things automatically, means the device is taking the decisions automatically nowadays. The AI is used to assist the doctor, but the independent decisions are not taken. But in near future, we will be seeing the things are being done automatically. Means the artificial intelligence is so much equipped to take the decisions, like to drive the car, and so many such applications. Now, if we see the statistics, 37% of business and the organizations employ AI, and this global market value would reach around to 67 billion dollars by 2027, and the AI is expected to contribute 15.7 million trillion dollars in the global economy by 2030, and more than 3 billion voice assistants are now used, but in near future it will be 8 billion, and we will be having self-driving car industry, and its worth would be more than $1,600 billion in the next 5 years. Now, can you suggest the problems that we can solve with AI? Any such problem in your mind? Yes? Yes, any problem that you think you can solve with the help of AI in the domain that you work, or anything that you see in and around, and you think you can solve it with the help of AI and machine learning? Yes. Yes. Any problem that you see?
Speed governor using AI.
Pardon?
Sir, speed governor in different terrains, different locations. Speed governor, speed limiter.
Okay. Very nice, sir. We can have the speed limiters. We can, yes, we can definitely solve this problem with the help of AI. Yes, definitely, sir. Any other problem? Any other participant? Okay. Let's move further. Now, question is, we have discussed about AI. In AI, we discussed that the machine takes the decision, and we are trying to mimic the human brain. Right. Now, if we talk about the machine learning, then yes, yes, yes.
Machine learning, we can that is diagnosing. So diagnosing the diseases easily to the human being using
Yes.
AI.
Yes, sir.
That is also
Diagnosing.
one.
Yes, diagnosing the diseases is one of the most important application of AI. Means
Yes.
whenever we are, yes, definitely very rightly said. Means with the help of machine learning, we can do lots of lots of analysis. We can get know the information through the X-ray with the help of AI.
Right medicine to right patient based
Yes,
on AI.
that yes, it would be a drastic research. It would be a game changer in the health industry. Means we are giving dose according to that patient. Yes, rightly said. Means as we get the personalized notifications, we can give a particular medicine, particular type of dose according to the patient. Yes, sir. Very rightly said. Now, we talked about the AI, and now what is the machine learning? This machine learning is the subset of AI. In machine learning, we utilize the data set and we are having the models to train. And then we have the further subset. It is the deep learning. Means these machine learning and deep learnings are this deep learning is actually the subset of machine learning. In deep learning, the task of feature extraction is done automatically. Means although in the machine learning, the characteristics about the data, information of the data is done manually, but in case of the deep learning, this process is automatically done. Means we are having the algorithm, it extracts the features automatically from the data set, and that helps us to get the training and testing on the data set. Most of the things that we are seeing in and around are basically the deep learning techniques. Now, if we classify these techniques, then we are having the supervised machine learning techniques, then we are having the unsupervised machine learning, then we have the reinforcement machine learning. In reinforcement learning, what happens? We are having results, and based upon the results, the algorithm automatically updates. Means if the results are favorable, then it is updated in one direction. If the results are not favorable, then it's updated in another way. Right, in this way we are having. Now, if we talk about the supervised machine learning algorithm, in this supervised machine learning algorithm, the most important thing is labeling of the data. Means we are having the labeled data set. For example, suppose we are having data set. Suppose we are predicting the salary of the employees of a company, and we will be having the labeled data set. That means labeled data set means corresponding to one employee, we are having the particular amount, corresponding to another employee, we are having some other amount. Right. In this way, the output is labeled, means we have marked that. Right. For example, we are classifying the colors of flowers, and then we know this is the this following information is related to this flowing flower. In this way, in this supervised machine learning algorithm, we are having the labeled data sets. That means we can say annotated data set like that. Then the training includes the input and the actual output. And what happens? We try to minimize the loss function. Loss function is nothing but a function that compares the predicted output with the actual output, and that difference, that loss function, is minimized in the supervised machine learning algorithm. Then basically, there are two types of supervised machine learning algorithm that we use. One is the classification algorithm, another one is regression algorithm. In classification algorithm, we are having the discrete or the fixed output. For example, suppose we are having sentiments, we are having the reviews of a movie, and we are classifying the review of the movie as positive and negative. That means in the output we are having the two classes. One class is positive, another class is negative. Another example, I suppose we are having a algorithm or machine, and that machine is recognizing whether whether there is a disease or not. Means we are classifying the person is having disease or not. Then it is also a classification problem, because output is two. Either that person is having a disease or not, 1 or 0. Right? We can have three classes as well. Right? Means we can say type of flowers, and those types of flowers can be three types of flowers can be there. Then we can say it is the multi-class classification. And then further we are having the regression. In this regression, the output can be any continuous value. As previously I gave the example, suppose we are predicting the salary of the employees of an institute, and that salary is not going to be the fixed output. The salary can be 10,000, 20,000, 50,000, 55,000. There's no fixed output. Therefore, these types of problems are regression problems that we see in and around. Then if we talk about examples further, suppose we are detecting the image. Suppose a vehicle is moving, and through its image, we are trying to recognize the vehicle. Suppose we are having the three vehicles running on a road. Suppose it is bus, car, and tractor. We are having the three images of bus, car, and tractor, and we are trying to recognize with the help of image whether that image is that of tractor, bus, or car, whether the vehicle is which one of the following is there. This is the example of supervised machine learning. And the customer sentiment analysis, whether the sentiments about a particular products are positive or negative. Then we are having this spam detection, whether the email is spam or not. And then we are having the predictive analysis. Now further, now what is unsupervised machine learning algorithm? Anybody can? Okay. When we talk about the unsupervised machine learning algorithm, then in unsupervised machine learning algorithms, we are not having the labeled data set. Actually, we are having the unlabeled data set to train the algorithm, and we try to find the pattern within the data. Suppose we are having some data set, and that data set is not labeled. Means the data set is not marked, it is not annotated, and we are trying to find the pattern. We can say it is similarity between the two things, and the various k-means algorithms, various unsupervised machine learning algorithms are like K-means algorithms, Gaussian mixture model, and there are various types of unsupervised machine learning algorithms that we use. And the examples of unsupervised machine learning algorithm is fraud detection. Means suppose there is a bank, and the bank wants to detect the fraud, whether there is going to be a fraud or not, and then we can use unsupervised machine learning algorithm to find the fraud. Means which one is the fraud in the customer. Then we are having the customer segmentation, means what type of customer we are dealing with. Then anomaly detection, means some unfavorable condition is there, something like some anomaly is there. Then we detect the anomaly with the help of anomaly detection. Then we can have the clustering, clustering the DNA patterns. And there are many examples that we use. Sometimes when we buy a product through Amazon, then we get the recommendation of a product similar to the previously purchased product. That is one of the example of unsupervised machine learning algorithm. Then in regression, we are having various types of regression algorithm, and one of the algorithm is regression algorithm. Suppose we are having this output, and we try to find a particular output, this formula, and we try to minimize the distance between the predicted and the actual output. And the various algorithms like root mean square error or the mean square error is used to find the values, to find the to minimize the loss. We are having the cost function. The algorithms like gradient descent is used. In this way, we get the predicted output. Then we are having another very simple classification algorithm. It is the logistic regression. And as the name suggests, regression, actually it is not regression problem, it is a classification problem. And in this logistic regression, the target data is categorical, means we are having the output in some categories, either 1 or 0. Then we use sigmoid function, and this sigmoid function gives the probability. Means suppose we are predicting whether the email is spam or not, then we can utilize this, and it will give us the probability. And if the probability is greater than 0.5, then we say it belongs to one class. And if the probability is less than a particular value, then we say it belongs to the another class. And then we are having another example, means tumor is there or not. Right? It is the classification problem. Now the cost function. This cost function is nothing but the value between the predicted output and the actual output, and we try to minimize it with the help of the loss functions. Sometimes what happens, our algorithm is overfitted or underfitted. The overfitting is means our algorithm is working very well on the training data set, but when we are utilizing this algorithm on unknown data set, then this algorithm is not able to perform well. Means on the known data set, on the training data set, it is performing very well, but not on the test data set. Means the algorithm is not generic. Then therefore we use some things like regularization and all those things to eliminate the overfitting. And sometimes we are having the underfitting, means the algorithm has not fitted well on the training data set. These are type of things we need to deal when we are dealing with the algorithms. Now there are various types of classifiers based on the based on the hyperplane. And most of the applications that we are seeing in and around in present era are based upon the deep learning. And when we talk about the deep learning, this deep learning is nothing but the deep neural network. Actually, the basic is neural network. And the work on the neural network started with the perceptron, and this perceptron is the oldest neural network. And in this neural network, we are having a single neuron, and this perceptron was developed by Rosenberg Frank in 1958, and it is one of the simplest neural network. And if we see it, if we see the perceptron, suppose we are having the inputs, and this is the weights, and this is the sum, and the output is nothing but it is the function of the weighted sum of the input. And if its value exceeds a threshold, means if it exceeds the threshold, let's say 0.5, then we say it is one class, otherwise it is the 0th class. Actually, you can see this this perceptron came into existence in 1958, and it is quite old, but we are seeing lots of application of deep learning in the present era because of the availability of resources, availability of the data set, availability of the funding, and availability of the very enhanced algorithms. And this support vector machine is also one of the very useful machine learning technique, and it is we can do with the help of this SVM. We can do classification, regression, and the outlier detection, means the outlier is there or not. And it is very effective in high dimensional data set, and it is memory efficient. Actually, we use SVM when we are having a small data set, because in the present era, most of the time we use deep learning or the transfer learning, but when we are dealing with the data set which is not large, then we use SVM. In the years 2012, 13, 14, the researchers at that time used SVM to perform the various machine learning tasks. In this SVM, we are having the various kernels based upon the data set, like linear, and then we can have the polynomial, and we can have the radial basis function, and sigmoid. Such type of kernels help to fine-tune the algorithms. Then it is having the various applications varying from customer service to intelligent direction, voice and speech recognition. Pardon? Hello? Actually, voice is not audible.
I'm looking at it, Dr. I am looking at it. Just wait.
Okay. Okay.
Okay, sir.
Okay. Okay. Am I audible? Some voice is there. Am I audible?
You are audible, sir. Audible.
Yes. Then there are various applications varying from customer service to voice and speech recognition, and these were some of the basic algorithms. But when we apply the machine learning on the algorithm, then machine learning for particular application, then the first step is to prepare the data. Suppose we are having the data set, and we want to apply machine learning algorithm on that. The first step is to clean the data so that machine learning algorithm could understand the data in a very well manner. Actually, as we say, garbage in, garbage out. If our data set is not pre-processed, it is not well cleaned, then we will not be getting the desired results. Therefore, the first step is to do the data cleaning. Right? Means what do we do? We clean the data. We see whether some NN values are not there or not. Means something is missing in the data set or not. Then we use data transformation. Then there is a feature engineering, means generating some new features and eliminating some features. And in one of the example, we will be seeing all these things. When we talk about the data cleaning, then we see whether the data type is same or not. Suppose we are having 3 features and their data type is different, then this data type should be same. And we see the range, whether the range is there. Then we see whether we are having the missing values or not. Suppose we are having missing values, some NN is there, then there is a need to replace those missing values with some mean, or sometimes we need to eliminate the row. And suppose we are having the outliers in the data set, and then task is to remove those outliers. Suppose we are having some duplicates rows, then we need to eliminate those duplicate values. Then we need to define categories. Sometimes data is there in some categories and we need to define it. Suppose it is bus, car, tractor, and we need to eliminate it with 0, 1, 2. And sometimes there are typographical errors. Suppose some user is giving the input and some error is there, some typing error is there, then we need to correct it. We try to minimize those errors, some typographical errors as possible. Then next step is to data transformations. We see if we require to filter out the values, if the data set is secured, then sometimes we need to scale the data set, then we need to deal with the categorical data set, data. Then feature engineering is about extracting the new features, finding the relationship between the features. If we need to generate some new features, we can generate new features. If we need to eliminate some features, that is also possible in feature engineering. Then we are having the feature representation, means we see how we can represent the features. And I show you in feature extraction, there are various, we can have the various real world examples, and we can see, suppose we want to predict the handwriting, then the features can be, we can take the features, means the image is there, then we can get the pixel value and we can draw the some features out of that. And I will like to show one of the machine learning algorithm here, means machine learning application. Can you see it? Can you see this example?
Yes, sir. Yes, sir. It's very much visible.
Yes, thank you, sir. And now this is the example. This is the example of sentiment analysis. Means we are trying to analyze the sentiments of the movie reviews. Means whether the sentiment is positive or negative. We are trying to predict. Now this is the Google Colab, and on this Google Colab, we can use the servers and resources of the Googles to work with. Now, as I said, the first step is to pre-process the dataset. We install the required libraries like CUDAs and Torch. Then we install the required libraries, and after then the first step is to pre-process the dataset. And this pre-processing, the purpose is to, if there is some missing value, we try to eliminate those missing values and do work on that. And when we take the data set and then we check the type of the data set, means it is IMDb, a movie review data set, and then we analyze the training data set and the testing data set, and we see those data set. And you can see one of the example in which we saw this at one of the local art movie theaters. And this is the review of a movie. And now these are the models. This is the machine learning model. Actually, these are the state-of-the-art models like BERT and DistilBERT. And then we perform the tokenization. Tokenization is nothing but dividing the whole text into splitting the text. Suppose we are having the paragraph, then we try to split the paragraph in lines, and further we split it into the words. And the next step is to train the model. Here we are using the DistilBERT model, and we write the code for it, and we train this model. And when this model is trained, after then we try to evaluate its performance, means how better this model is. Then we use this accuracy and the F1 score to predict the yes. Any question? Can you hear me? Any question? Yes, sir. Any question?
Yes, sir. You carry on, sir.
Okay. Then we are having the training model. After then, we evaluate this classification problem with the help of performance parameters like accuracy and the F1 score, and we can set the various parameters. Means what is going to be the learning rate, what is going to be the best size, and then we can also analyze this model on the new data set. Suppose I have this movie, then this model, the sentiment model, can give you the performance. Any doubt in it? Any question? Any doubt in this? Any query?
Sir, you carry on. We can take the query at the last also.
Okay. This is the these are the performances that we use. Means this accuracy, F1 scores, and all these things to visualize. Means what is the performance of the model. Actually, it would take a bit time to run, and by the time you can also ask the questions, because this model training will take us the time, this training and evaluation.
Sir,
and
one question we received on.
If you have any question.
Sir, one question we received on our live streaming on YouTube.
Okay.
That,
what is it?
What about this collab, sir? How much resources we can access, like in terms of machine, RAM and processing? Is it our own machine, or Google is providing some assistance in that also?
Yes, actually, Google is providing the resources. Means it is working. It is providing us these resources. Means actually, we are having this Collab. Then we are having the Collab Pro. Then Collab Pro Plus is there. But this version that I am using, it is free of cost.
Okay.
Means we are utilizing the resources of the Google, and we can also access the GPU of the Google as well. And this is the thing. Means this is quite easy to utilize. You do not need to install any software on your computer. You just go and write Google Colab. Then it is going to give you the notebook, and you can work on that.
Okay, sir. Thank you, sir. Carry on, sir.
Thank you. Yes, this was the example. I mean, such type of examples we can do with the help of the machine learning. Any query? Any query regarding this these performance parameters and all that, you can ask. I'm not able to hear. Yes, any query? Any query? Any query in this?
Request
No,
the participants to pose some questions, any queries, please. Sirisha madam, your voice is not audible.
If you're
Yes.
not, you can also write it here. Yes, if you have any query, you can write here. This is one of the example of classification algorithm, and this is from my side. If you are having any query or anything that you want to ask, you can ask me.
Okay, sir.
Thank you, sir.
Thank
you, Virendra sir.
Yes.
And I will share you these slides and Google Colab later.
Sure, sir. Sure, sir. We will distribute among the participants.
Thank you, sir, for spending your valuable time and sharing your knowledge upon artificial intelligence and machine learning. Thank you.
Thank you, ma'am.
Now I call upon Dr. Virendra Singh, sir, to introduce our guest, Vinay Lochab. Dr. Vinay Lochab.
Thank you, madam. Thank you. So, this is the last session for today. And for this session, we are inviting Dr. Vinay Lochab. Is a data scientist working in data ORB, and he worked in medical imaging. His area of expertise in medical imaging and natural language processing. So Dr. Vinay Lochab, as per my knowledge, is a great mathematician, but have educational background in electronics and communication, then turned into data scientist. So major areas: fine-tuning the Roberta model for sentiment analysis, fine-tune the Roberta model for intent detection, tuning the Roberta model for question answering to extract the information through text data, text clustering based on k-means and HDB scan, weak labeling and contextual search using SBRT. So one thing is learning, know about machine learning or Python, and the other thing is about application. How you are going to use this strong technological tool to help a human being in a more way. So I request Dr. Vinay Lochab to deliver a talk on data science for medical application. Please, Dr. Vinay Lochab, sir.
Hello.
Hi, sir. Audible. Sir, your face is not. Please adjust the laptop. Now, sir. Visual, sir.
Okay.
Please start, sir.
So, good afternoon, everyone. Thank you, NSRT and Dr. Virendra Singh for organizing this wonderful FDP program that we are able to get the views of like very senior guy, Dr. PK Khosla sir, Dr. Manish Kalra, and many more to come in tomorrow's and the day after tomorrow's session. So I will be sharing a little. So let me start. So is my slide visible to you?
Yes, sir, visible.
Okay, so now data science is a very fascinating subject, as we all know. So everybody is it is a talk of the town. Everybody thinks about data scientists like it is a big booming area, and everybody is expert in that. And there are many opportunities also. So I'm also one such guy who thinks like data science can do wonders. And last year I like go more into the practical aspect of it. Before that, I was more exploring the research part. So I'm working as applied scientist and in the data ORB. And so my first question to everyone, like, what is the data science? So we know, like, even if we are going to buy a simple product, either through the market or through the e-commerce website, we generally ask for like we go for the reviews, whether it is from a colleague or through the Google or through any website that is available like Quora and Fishbowl and whatnot. So the purpose behind it, to get the meaningful information out of all the reviews or all the information that are populated on these channels, on the different forums. So the data science is nothing but to extract the meaningful information that might be related to business here, or it might be related to our research purpose. Like if somebody is going to diagnose maybe cancer through thermal imaging, so here the data inferences or data science will be used to extract that meaningful information, and all the steps will fall accordingly depending on the final purpose that we are going to have. So this is a very broad definition. Like it is a multidisciplinary approach where we combine the basic stats and then artificial intelligence and some concepts of computer engineering. So means there is a myth behind it, data science, like it is all about AI and data, all about AI and deep learning. It is not. Actually, first thing that we do, we tend to get the data in the proper format, and we also get to know what are the sources from which we can get the data. So like suppose for any corporate reviews, if you are going to search on maybe Wikipedia, you might not get any review at all. But if you are going on like Fishbowl or Ambition Box, you might get better reviews about the companies where you are going to apply in. So means these kind of steps are there. So means we should also apply our common sense into data science. So if you have common sense and little bit of mathematics, I think you can be a data scientist. So in my work here in the data orb is mainly related to natural language processing, where I do the model training for the text. For the text, I do like I classify the text into different labels that we require for purpose. We also extract the meaningful information, like what are the key phrases. You will get to know in the further slides what is the meaningful information here. And then we are also extracting other attributes also, like whether maybe like suppose our client is Apple, and Apple is recently launched iPhone 14. So how many times the person is speaking about iPhone, and what features they are speaking really about, what they like, what they don't like. So they, like there are tons and tons of information that are present, but they are not in structured form. So to convert that information into structured form is also an like application of data science also. And before working here, I was working mainly in the medical image processing. And so I will be discussing one application related to that, that will be total knee replacement, the analysis of patient who are undergoing the total knee replacement surgery. And we are doing it with the help of thermal imaging. So like this is one example. So like somebody has written one thing, this Pixel phone is amazing, I loved it. So how many information can we get from it? Like first, why the person is writing the post itself. So the reason behind it, the person is appreciating it, the product. So one information might be suited for a Google Pixel, for a Google is like their Pixel phone is amazing and people are loving it, and the sentiment around it positive. So that means the person is speaking, appreciating, and talking positively about the product. Now what they are talking about, the Pixel phone. So the key phrase could be like Pixel phone is amazing or I loved it. Both could be the key phrases here. So similarly, like there are many text, the text could be classified into many forms. One is the sentiment classification that our previous speaker, Dr. Manish Kalra, explained. Like the person might be experiencing might be writing something positive, something negative, or maybe neutral. Like he is just stating the facts, like the camera of this phone is 13 megapixel, that's it. Or he might be also giving the mixed sentiment, like he likes some part of it and he didn't like some part of it. So these are the like different tasks, like intent classification, like the why is writing, the key phrase extraction, like phone is amazing, question answering. Like instead of we have full paragraph, like we generally write the research paper, and in those research papers we don't know like what is the crux of the whole paper. So we just ask a simple question, like what the paper wanted to conclude, we will get an answer. So the deep learning, like the text with the help of transformer, the NLP has advanced tremendously. Like we just have to ask simple question and we will get the output. Like we will get the conclusion of the whole paper into like single sentence or maybe two sentences. And the clustering, like all the similar, like we know that the papers that we search, we go through the different journals, and it is very difficult to find, and very so we can generally scrape the whole data through the website, which are publicly available, of course, and we can simply apply the clustering technique, like which are more similar, like we can compare their abstract. So if their abstract are more similar to each other, we could put them in one bracket and others in other. So data scraping. So first part is this data scraping. Like we needed to know, like for which kind of data we need to search where. Like generally the sentiment data that is related to consumer electronics, we might find on the Chroma stores, Amazon, Flipkart, these kind of things. For other kind of I think for other kind of problem, we find the data on the different subject pages. Like for Wikipedia is helpful when we are going to get the database for a particular like maybe historical some lessons or some kind of these problems. So data augmentation, so means these are the different parts in natural language processing that we could do. So like I try to tabulate them like step by step, like how journey of a data science project starts. So first step is the data gathering and data extraction. So means how we are going to source our data, whether it is going to be given to us by some client, or we have to get all the freehold data that is available in public, like from Twitter, Reddit, YouTube, and again these e-commerce platforms, or maybe some we can also use some websites which do these things. Then the second thing, the most important thing after getting the data is put them in a proper format. Like the data cleaning is essential. Like if we are scraping the data from maybe Twitter, we are getting at the rate, and many like stop words are there, like this is the. So I think is or the is of no use here in the particular text, because they are not going to explain us why the person is writing those reviews. So means those kind of data cleaning steps is also required, and those data cleaning are specific to the end result that we require. For certain tasks, we might remove the hash marks which are available in the Twitter post. For some, we might not. So means because they might also have some important information, like which hashtags are more like they are trending or not. So if we are going to focus on the trending application, then we can't remove the hash words from there. Otherwise we need to. And the third part is the data analysis. So after cleaning the data, now suppose we are going to analyze the data. So the data should be like suppose if it is real-time data and we are going to analyze it through statistical method, we should know what form of data it is, like whether it is following the normal distribution. So we can apply all the parametric tests that are available, like t-test, ANOVA test. Or if it is non-parametric, then Kurzweil, Wallis-Tal, Mann-Whitney test, these kind of tests are there. And even to check the normalcy, suppose sometimes the graphical representation of data cannot give us the real picture. So what we can do, we can use the Anderson-Darlington test or these kind of tests, which are just used for normalcy test, normalcy check only. We can also, like suppose if you have domain knowledge, and if I give you, like we have to predict whether the person is overweight or not, and we are only giving you the age of the person. So is this going to be useful to you? No, because for overweight we need BMI, for BMI we need weight and height. So these two are the most important information, and other information, if they are supplied to you, you have to remove that. So these kind of information you would get from the data analysis. So data cleaning and data analysis, they are sequential, but that is not the proper order. Like they can be combined as well in some applications. Now algorithm. After doing the data analysis, the data science project could stop here only. So suppose like if we are going to do some hypothesis testing, which I am going to show you through my the medical project that I have done. So it could stop here only. Like if we are going to hypothesis, like whether the person has cancer, like maybe the thermal image we are going to use. And if you are saying like that high temperature regions correspond to the cancerous patient. So this is our hypothesis. The null hypothesis would be the patient like high temperature regions do not correspond to the cancerous region. So we could simply use collect the data of the different patient, extract the temperature, the maximum temperature of that region, and then do the t-test if the data like more than 30 and following the normal distribution. So and then we based on the p value, we can conclude whether our hypothesis is correct or not, whether it is able to reject the null hypothesis in favor of our or not. So data science project could end here also, or it could start from here, because generally people think the project start from here. So that is the myth about data science. Now algorithm that Dr. Manish Kalra has explained, there are many algorithms. We could use SVM, we could regression. Suppose if you are going to predict the prices of house. So regression is of course the good problem. XGBoost is also there. So depending on but the data analysis part will give you the insight which algorithm you are going to use for your own purpose. If you are not going to focus on it, the data analysis part, I think you are not going to get the the gist of it, like which algorithm you are going to, and you are end up maybe for some algorithm you needed to use the simple classical ML, like maybe logistic regression for classification, and if it is a binary class problem, but you are going to use the Hugging Face transformer, which is going to take huge memory as well as your resources. So that kind of insight you only will get through the data analysis part. So, and then of course, based on data analysis, you will select your algorithm, whether it is a basic statistical method, whether it is the ML, whether it is the deep learning. So, and at the end, you will do the validation. So you will have some data which is not seen by your algorithm at all. Generally, that thing is applicable for the what you can say this the machine learning or deep learning approaches. Okay, so through this you will know how much your algorithm is you can say performing on the out of sample data, and based on this data only that our previous speaker Dr. Manish said, overfitting and underfitting, that problem is occurs. So suppose if on this data our model performs deteriorate drastically, it means our model has overfitted. And even while training itself, the model accuracy is not large enough, it means our model has underfitted. So these kind of things we have to take into account. And suppose our model is not good enough for in production, like for the real-time application, then what we'll do, we will gather more data, we will clean it, we will analyze it again, we will retrain our model. And if all these steps, first 6 steps are checked, then we are going to deploy our model for practical purposes. So these are like a journey of any data science project. So let me share. I will take all the questions after the my lecture. So let me share.
Okay, sir.
So is my screen visible?
Yes, sir. Yes, sir.
So I have just I did one project that is related to article classification, like based on abstract and title, could we able to classify articles, like whether it is falling in which category or not. So same thing which Dr. Manish Kalra has said. So we can use the Google Colab, and the question to that person was with Google Colab. So Google Colab is nothing but a virtual machine. You just need an internet connection. If internet connection is good enough, so Google Colab is fine. And even if Google connection, your internet connection is not that good enough, then you need Google Colab Pro, because in that your what you can say program will not be disconnected frequently, because you will get a longer access, and you will also get the support of GPU, means the more computing power you will get through that.
Yes, sir.
And Google Colab Pro Plus is another, which is another high-end variant of it, and depending on this, they are the costs associated with it. So Google Colab is free. So if you are going to write some small project, then you are going to use it. And why we are going to use it? Because generally when you are going to use Python or any programming language, there might be conflict in the libraries that you are going to use for the different projects. So Google Colab is you won't find that kind of problem here, because every time you're going to open your new project, it will be a separate environment for your application. So you don't have to worry about the, suppose earlier you might have used the maybe Pandas 2.3, and now you are using the different variant of it, or maybe TensorFlow earlier you were using 2.6, now you are using 2.9. So there might be conflict. So by using Colab,
sorry, sir. We are looking at. Done, sir. Done, sir.
So these are the steps, like you have to just run first. This is nothing but the installation part, like the library will be installed from this, and then these are the steps. Like you have to import all these library, like stop words which you want to remove. You have to tokenize the words. Tokenization means instead of passing whole sentence at a time, you will pass them word by word. Means they will be list of word instead of whole sentence.
Sir, you have shared new collab sheet now.
Yes, yes.
It is not visible. Please look at it again.
Okay, so that is what I was asking.
Sorry.
Reshare the screen, sir, once again.
Okay, I'm sharing.
Reshare.
Is it now?
Yes, sir. Yes,
it's
okay.
Visible now, sir.
Okay, so in the first step, you have to install the library. Like you can use the simple syntax pip install and the library name. So I installed the sentence transformer library, which is nothing but the package on the top of transformer, which gives you very it is very flexible. In you have to just give the different parameters that you want to set for your model, and your model will be trained. So like these are the nothing but the pre-processing step, like the remove white space, clean text. Another problem that the we researchers we have, like while doing research, we don't follow the good code practices that we should follow. Like we should use the oops concept. Like we should divide the particular functions depending on the task that they are doing. Like the clean text will do all the if they're at the rate signs are present, all the URLs that are present other than the words, these at the rate A to Z 0 to 9, other these symbols, anything is present. So these kind of things will be removed by this cleaning function and the stop words. Now then we will do the pre-process. So let me show you. So you just have to run them, and these are all the training argument, like whether you need to reprocess the data. So now because I have connected my Google Drive with Colab Pro, so another flexibility is you can add your data to Google Drive, and through Google Drive you can access to the Google Colab. So so I think maybe 30 GB generally we get in the Google Drive. So 30 GB data you can upload and you can import in Google Colab. And so these are all the parameters, like do you want, what is the output directory that you want, what is the best model that you want to save, evaluation during training, like do you want to validate while training or not, maximum sequence length. So the limitation of Hugging Face transformer, simple BERT or Roberta model is they can process only 512 length of token. So that is the limitation. So that's why we have put the maximum limit, because here for this application we are going to use the title as well as the abstract. So the length would be bound to be around that number. So how many epochs that you want to train, so means you can hyperparameter, these are the hyperparameter, and you can tune it for your own purpose. These are the learning rates. So generally what I did, I gone through the many literature papers what they have done, but you can also experiment your own, because I didn't have the resources for that time. So that's why I did that. And this sentence transformer also gives you like this thing WhenDB project, weights and biases. This is a website which gives you more insights to your model. So one problem we face in the deep learning models is that we don't get anything, like why the decision they are making, why they are making. We can't put any logic behind it. Everything is black box to us. So there are many like SHAP, and there are another platform, they are giving us that insight. So one such is WhenDB. So weights and biases. So it will integrate your project into that account, and you can see how much your per epoch, how much training error is getting down, and what is the validation error. So based on epoch and epoch, where your model is overfitting. So it can also help you guide that. It will give you visual analysis. So like this is the batch size here, train batch size, eval batch size, and like this is our test data that we had. So title and the date that we published, abstract, and the subject. So it is a multi-level classification. So a particular abstract plus title, so text could be classified in more than one categories. So it might be astrophysics, general relativity of quantum. So if you see, so oh, so actually this is in form of list, so you will get something like this. So astrophysics, high energy astrophysics phenomena. So this is different. This is different. Astrophysics, solar settler. So this is count how many times they are appearing, and this is the exact label which are there. So this is not the correct way because it is in form of list. So it will give the how many times the list is present over there. But you can see this kind of label is present 4,408 times. So now at the end, you just have to train the model. You can simply give this command train model train, and these are the arguments that we have supplied previously. The train is nothing but the train data. That's it. Then your model will start training. Now there is another inference script is written. So now in inference script is also, but nothing. We have to use the saved model, which we have trained above. So all the steps like cleaning and all will be follow here. Like, so it will be article classification class that we have declared. And we just have to get this article. So this final function get article, it will give, so we have to give this three information: title, abstract, and it will give us the subject, like which class it will belong to. So it is as simple as that. So same problem could also be taken by logistic regression. And also, so this is where we are going to do like article classification. Model name is Roberta. Model path we have already because we have stored in that output directory, we will give, and this is the data we will give. And then from that object of class, we will call the function get article and data. And here the new label will be, the new column will be created that is related to the predict subject. So this is that simple. So this is the first part of it, where I myself, even by claiming that data science is not about AI, ML, and DL, I have first give you the glimpses like deep learning only. Now I will move down more on like hypothesis testing and that kind of data science project. So it is a very long slide. I will be sharing my screen. So is the new slides is visible?
Yes, Dr. Vinay, it's visible, sir.
So another project that we did, it is related to musculoskeletal injury. So that I told you, that is totally replacement. So firstly, the musculoskeletal injuries, all the soft tissues that are in our body, which help us our body to give the structure that they have, like the bone and all, they give the hard structure, and the soft and movement part will be given by these soft tissues. And generally what happens that with time, these muscles or the different parts of the muscles, they tend to deteriorate their functioning with time, maybe with age, or maybe due to some accident, or maybe due to overuse simply. So they have like group of disease. So what I focused on that arthritis, and arthritis I worked on the osteoarthritis, and especially knee area. So you can see the redness, the warmness that we feel around our knee. It is like this joint will give you the best, this picture will give you the best example. Like this is the normal joint, the orangish is the synovial fluid, and this whitish is the rubbery substance that we called cartilage. And this is the like tibia and femur, these are the like normal knee joint. But what happens in osteoarthritis, this cartilage, this white rubbery substance, it starts decreasing. Means its length, what you can say, its width deteriorates. So either it might be due to the person is overweight. Generally the knee osteoarthritis is the disease that we associate the person who was overweight. So this problem is related to that. I think I need to, is there pointer option available? Yes. So this is the white rubbery substance that I'm talking about. This is cartilage, and you can see if the person having arthritis, there is no sign of there. So generally what happens if the person is having grade 4 disease, so doctor opted for a surgery, asked the person to go under the total knee replacement surgery. And what they do, they replace the original joint, cut down, and put the artificial component there, call them as prosthesis. And what we do as of now, we use we put in the syringe, we take out the blood, and then we take out the different markers like ESR is the arthritis, arthrocyte sedimentation rate, C-reactive protein, and interleukin level 6. So these are the like, there are many more as well, but these are the inflammatory markers, the sign of inflammatory markers, whether the person has recovered or not. The problem with that is every time we have to take the blood out of a patient, and it is very like the patient might develop infection due to that thing only, and it is invasive in nature. So that's why we focus on whether we have any alternate medium that could be explored for that very purpose. So the thing is, we explored the thermography, and thermography is non-invasive, non-radiative, offer privacy, fast, reliable, very helpful in monitoring. And what will we do? I will explain it in further slides. So in simple terms, it is nothing but it captures the heat radiated our body and convert into visual form. That's it. And this is nothing that law, the Stefan Boltzmann law explains that thing only. W is the radiated power, A is the area. So radiated power per unit area is directly proportional to the 4 to the power temperature. And epsilon is the emissivity, and for human body it is found to be 0.98, so it is close to 1. It means we can approximate our temperature of the temperature of our body into some form of visual. So you can see here. So this is a visual image. You can see there is not a iota of difference in the patient physiology, but the right, you can say the right leg, it has fracture in it. You can see clearly because these white spots are there. Here white spot means the patient having the highest temperature here. Okay, and the blackish which you can't see, so you can see blue is the lowest temperature here. So this kind of insight could be given by thermography. It will, if the person is normal, we will see the same thing, like this is reddish and what you can say yellowish, so there is no reason. But the white reason is the person, you can see like it is the patient is having fracture over there or some kind of abnormality. In case of it might be low as well. Sometimes everything will be okay and that reason will be low. So it happens generally in case of diabetes. So generally if there is enough contrast between foreground and background, like in this case the whiteness is clearly visible, we go for the passive thermography. Otherwise we will heat that part of body using active thermography. So this is the like overall how thermography has come about it. So I'm not going to bore you about this limitation, and these are the literature surveys. So generally whenever we are going to hypothesis something, we have to do this way. We have to first do literature survey, then we do what are the state of art happening over there, and then we could find the gap that is available in the literature, so that we could work on that. And so first step of working after that is to formulate your protocols, how you're going to get your data. So we have taken the data of the patient before the operation, on the like first day before the operation, then on the second day after the operation, then on the 6th day, 15th day, 45th, then 19th day. And the other protocols where patient should not be containing any fever, we should put the camera 2 feet aside, the temperature and humidity are in these ranges, and these 3 views will be captured. So this is overall flow, what happens there. So this is the patient knee photograph after operation. You can see these are sutures over there. So they are less visible, but they are there. So we first use the thermal imaging, then we extract the high temperature regions, then we capture the, like from high temperature region, we calculated the mean temperature. From that mean temperature, we calculated the mean differential temperature. Mean differential is this because we believe the patient will be recovered fully if its temperature reaches to the preoperative level. Okay, so if the patient temperature before the operation is 32 degrees Celsius, after the operation, whenever it reaches to 32 degrees Celsius, we would say the patient has recovered fully. And that for that ascertainment, we also do some statistical tests like 2K on a significant difference test and Pearson correlation test will be done with inflammatory markers, the clinical ground truth that we had. So this is the patient demography. So you can see the BMI that I told in earlier examples, the data science problem, if we are going to get the patient is obese or not, or overweight or not. So the BMI and the osteoarthritis disease is also nothing but this is weight centric disease. A person is overweight, he's bound to get the osteoarthritis, and in future, like he might also undergo the total knee replacement surgery. So now this is the data analysis part that I was talking about in the data science project. So this is the clinical ground truth. First it increase until first week and then start decrease. This is the CRP, it will start increase and then decrease. So this is the thermal segmentation part, like the image segmentation part, which is of no use here. So but if you see here, when we calculated the mean differential temperature, this is the pattern it follows. So you can see it is closely following the pattern as followed by the ground truth. And we have to suck in the blood into injections, and we have to do all the tests from there. It take time also, but here it doesn't take any time. You just have to take the photo, pass it through algorithm, get this line graph immediately for a patient. So you can see like what is the temperature difference. So on the second day it is 2.5 degree. So these temperature difference are compared to the first day. So you can see on the 45 day generally the patient has recovered. So you can see the temperature has decreased to the preoperative level. So this is just to visual analysis. So if you get more insight about the data, so you can create your own parameter to assess whether the patient has recovered or not. So this will be helpful both for patient as well as doctors, because that is pure science, and it is pure, you can say, the practical purpose of that science through this parameter. So that is the percentage, like how much percentage of knee is still inflamed. So you can see it is 80% here. It is 40% on 15 day, and it is around 20 or less than 20. So you can say on the 45 days patient has recovered, and because we have taken all the knees and different patient has different preoperative temperature, so that's why the error bar is very high. And this is the post hoc 2K SSE test, because whatever we are saying, whether it is making sense or not, for that we also need some statistical test. So that's why for all these different views we have performed, and you can see what are the p values, very, very significant. But if you see from first and 45 days, it is not. It means on the 45 day the person has recovered fully. And this is the correlation story. CRP is the inflammatory markers that we use as of now, ground truth. MDT is that we have captured through thermal imaging, the mean differential temperature. And you can see it is very high correlation. It is in very high correlation with the Pearson correlation coefficient. So in the inflammatory markers. So you can see, means whatever we could do through the clinical, like inflammatory markers, we could also do through thermal imaging. So that part is also nothing but the data science, like how you are going to take the data, what the protocols you need to follow, how you are going to analyze it, in what form you are going to put it. We have also used Anderson-Darlington test to ensure that it follows the normalcy. So, and then you can reject or accept the hypothesis, because after that, if you have done the hypothesis, another thing is you have to capture more and more data. That's it. Then at the end, you can simply use any deep learning or ML algorithm. That's it. So again, so one paper was published related to that study. So I think that's it from my side. So if we have any questions, so we can take that here.
Yes, sir. First participant, any question, please ask.
Yes, sir. Good evening.
Hello. Yes.
Carry. Please.
Sir, actually, I belongs to electronics and communication engineering.
Okay.
And we are very fascinated about these data science and artificial intelligence and machine learning. But could you please tell about the differences between the data science, artificial intelligence, and machine learning?
Actually, there is no such difference. So like the data science is the basic part. Only like if you are only going to use the stats and the different histogram and the board plot and the different kind of simple plotting and visual analysis, if you are going to do, or statistical analysis, it means you are going to fall more in terms of data science. Okay, but the same data science story is also being used by ML and DL, because we also got the metric over there, like accuracy metric, F1 score, and all these things. Even the algorithm, no. So all the ML algorithm, they are nothing but based on the mathematics, and data science is also nothing but mathematics. So that is some advanced form of basic stats. So you can say data science is helpful both in MLDL and a normal simple data analysis tools.
Okay, sir.
Dr. Vinay sir,
Yes.
I would like to add on this because nowadays, if you see every ad on YouTube or any platform, data scientist, data science.
Yes.
So, who, which profession, which student or which faculty member should go into this field? Means you have shown that using data science miracle, you are completely utilizing, you are playing with data to help in medical for healthcare system. So, what are the targeted audience of means input researchers whom should go to this field? So, what is
Actually,
the background
that
or
is
prerequisite is required for this?
yes. So it is a very good question. So generally, the people thinks which are good in mathematics, so it is for them mainly, or maybe computer science background student. But the thing is, everybody, like even if we are going to make any decision in our real life, we also rely on data. And now you are getting so much recommendation on YouTube videos and everywhere of data science courses, because now we have data with our hand, like with the 4G and the Geo. So everybody's data is online. Like if you go only simply Facebook, and if I cite any location, maybe Delhi, I will filter, so I will get like 1,000%. So we can know now, first thing is how many persons are from Delhi on Facebook. Second thing is how many are graduates. Third thing is where they have been in like last 1 year. Fourth thing is means this is like nothing but the hierarchies of filters, and based on that we can like you can say empowers different clients. So that's how meta works, Facebook works. So they then share these data to the different clients of the companies, and they based on those audiences make their decision. So what I'm trying to say, even suppose I'm going to buy a house.
Yes, sir.
I am a normal person who is coming from rural background, haven't gone across any like normal school education. But even while buying a house, I will consult with various persons. I will go whether the hospital is nearby or not, whether bus station, how much distance it is, railway station, whether roads are proper or not. So these means I'm doing nothing but data analysis only.
Yes,
but I cannot put it into in form of like data science. Like I'm not using any stats. I am using, but I don't know which stats I'm using. Okay.
Yes, sir. Thanks for this beautiful answer, sir. Because nowadays, so many people without having that much interest, but still they go for it as a fascination or like any money.
Yes.
Or like that. That's why I asked it. Before I ask our HOD sir to give instruction to the participant. Please, dear all participants, please switch on your camera. Please switch on your camera, because from the beginning inauguration to till now we are not able to interact with you. Please switch on your cameras, and HOD sir, please if you want any conversation with Dr. Vinay Lochab sir.
Thank you, Vinay sir, Dr. Vinay Lochak sir. Thank you very much for your day here. A nice presentation, and we could get some info out of it, definitely. So there are a lot more to go from next 2 days. So tomorrow there are 3 sessions. So sessions 1 starts at 11 to 12. And session 2 is from 1:30 to 2:30, and session 3 from 2:30 to 3:30. So tomorrow, so session 1 is will be handled by Dr. Sachin Kumar Srivastav.
Sir, session 4 also, sir. Session 4 also.
4 also.
I will share the updated schedule.
Yes. So who is going to talk about plasmonics fundamentals to applications. So we have beautiful sessions ahead, and the updated schedule is already shared in the group. Please look into it, and we request all the participants to be present during that session, so that more interaction will be useful for everybody. So if you interact more, we can get more info from the resource persons. More we can get more thing out of it from everybody, and after session day, after every day, we are going to send the feedback link to the group as well as in the chat box here. And it's mandate to have 80% attendance as I've already told, 80% attendance, and as well as the feedback link should be filled by the members. The outsiders, those if you share also, that won't be considered because we are going to take all these complete, we are monitoring. So even the outsiders, those who fill without participation won't be get any certificate also. So I request all the participants to be fill the feedback shared to you right now. And the feedback link will be expired within 15 minutes also. Please kindly fill it in time. And I request Mr. Sultan to take a group pic. I request all the participants, members to switch on your camera first for a group photo, group pic. Sultan, have you taken?
Sir, I have shared the latest schedule, FDP schedule in the group, sir.
Yeah, sure. And I request all the participants to have healthy interactions so that we can get something out of it. And thank you very much for today's speakers, Dr. Manish Kalda sir, and the chief guest for today's inaugural, Dr. P.K. Koshla, Pro Vice Chancellor, Kara University, Punjab. And this is the day one, end of the day one. And I thank you all the participants. Thank you.
Sir, feedback forms.
Yes, we have shared the feedback link in group.
Dear all participants, Google form is shared already. Complete schedule as well as your feedback. Please make this FDP to enhance your skill set or to know more about the recent trends, what is happening in computer science and electronics. So a lot of interesting lecture is yet to come on MEMS, on plasmonics, on nanotechnology. And one more lecture we have added but the last lecture one on Saturday, how to write research proposals. So please find this updated schedule. And before leaving, please fill this Google form. If you have filled that Google form, then you can leave after that. And Dr. Vinay Lochap ji, बहुत धन्यवाद सर. आपने इतना समय निकाला उसके लिए बहुत शुक्रिया. और आपको
pleasure is all mine.
हाँ, आपको विशाखापट्टनम NSRIT विशाखापट्टनम की तरफ से राम राम.
जय श्री राम.
Okay.
Thank you, sir. Thank you, Vinay.
Okay, sir. Those participants who have filled this Google form, they can leave.
Yes. Thank you.
No participant should leave the session without filling the feedback form. It's mandate. Thank you.
Please fill the Google form and then leave.
Who did you?
Sir.
Respected participants, the link for the feedback is already in the Zoom as well as in the YouTube live streaming. Please check the live chat for the feedback link and attendance link. They both are in a single link, that is a Google form. You have to accept it and you have to fill it. It is mandatory for all.